regularization and collocation. If you remember when we explained X gap based on the collocation was cross covariance, autocovariance plus error covariance function multiplied by n. That was the principle. And if you remember the spaces that I drew X and L, I mentioned that this LL can be written as RCX X E transpose. And I explained that this can be CXX A transpose based on that. So let me rewrite this equation based on that principle. So write it completely here. X tilde. There is an identity then that we can use later for this inverse. But before that, let me explain a principle. Maybe if we call this M, that will be. Now let's look at M inverse. M inverse so how can we proceed? I assume that this one will be Y. A will be U. C will be X. Okay, this is, and this will be V. This is the Z. Therefore, so what I have got actually was M inverse. Then if I want to work further with this, then I multiply C epsilon epsilon. That's from left side. I do it from left side. Of course, it doesn't matter practically because they have the same dimension, actually. Then we clean this part. So we are almost there. What was the equation for the X was? This side, A transpose C epsilon epsilon. So if I multiply both sides of this with A, this CXA is actually this C that I have defined it here. And this is nothing than M. In this case, well, based on the definition that I have, and I have proved that CM was this last term that I'm showing now. Let me clean this part. Now let me go back to the Tikhonov regularization. Tikhonov regularization minus the norm of the estimate plus A2 norm of the residual and norm of the estimated parameters are minimized. And alpha 2 is a constant and small value. The variance covariance matrix of the measurements here was this one, the noise of the curve. And here we have the metric of the space Cx inverse. Then we do not have zero order. We have a second order, I think second order Tikhonov regularization. And if I solve that Tikhonov regularization based on this minimization problem, I come to this solution. And now this is Tikhonov regularization, and the one above is square collocation. What do you see here from these two? From this one and this two. Yeah, there's the only difference is here. If alpha 2 is 1, then it will be this square collocation. Alpha 2 equal, then it will be Tikhonov regularization. So there is some inherent connection between regularization, Tikhonov type, and this square collocation. And as you saw, I could come from the well-known formula, right from the beginning, for this square collocation. I changed this to X cap is a transpose epsilon inverse A plus C X A transpose C epsilon inverse A. And this is exactly what we have in Tikhonov regularization. So it means that if we already have the covariance function or autocovariance function between the unknown parameters, which is this one, we have extra constraint and we have the covariance between them parameters, we can estimate, we can use them to regularize to get a smooth solution. So these two types of equation are actually equivalent. You can use either of them for getting a smooth solution. But if you want to be more, then you add alpha 2 here, but it's not equal to 1 anymore. Then you will have Tikhonov regularization of the third order, if I'm not mistaken. So the second order, zeros, second order. So we always assume that this covariance is 1, I, identity matrix, no covariance. We just add a positive value, a constant positive value to the diagonal elements of the normal coefficient matrix. But in this case, not only that, we already have this bias covariance information of the unknown parameters, and we multiply a constant positive value to that matrix, then thereafter add it to this matrix. So I hope you enjoy and like this lecture about regularization and collocation. And I could help you. I hope that I have been successful to help you understand the concept.